All right, I'm going to try to really help you relate to what stoichiometry is all about. Um, Hopefully, using this analogy, it'll make sense to you, and you'll see that it's not as hard as it people make it out to be. So I've got a ham and cheese sandwich. So let's look at what I need for a ham and cheese sandwich. I need 2 pieces of bread. I'm going to write a balanced equation. So that's my first element. I need 2 pieces of bread. My second element is I need 1 piece of ham. And then I need 1 piece of cheese. That's going to produce 1 ham and cheese sandwich. Okay? So that's my goal, is to get a ham and cheese sandwich. Now, this right here is the mole, or how, the what I'm going to be using to make a mole ratio. And guys, I know you can look at this and tell, if I give you amount of something, what it is. And that's the goal of this. I want you to see that stoichiometry is not that hard. And the whole purpose of it is, if I tell you I have this amount, how much of this can you make? Or if I've made this amount, how much of this did I use? So putting it into this ham and cheese sandwich example, I'm hoping is going to make this kind of turn a light bulb on. So let's say that I gave you 6 pieces of ham. Okay, you have 6 pieces of ham. And my question is, I want to know how many sandwiches. All right, I know you're looking and thinking, Miss Baker, that is like the easiest thing in the world. You're going to make 6 sandwiches. Yes, but I'm going to show you how you can use stoichiometry to figure this out. Because when we're doing chemical compounds, it's not going to be that simple, okay? So I know that I've got 6 pieces of ham. So the first thing we always do is we write down what we're given. So I have 6 pieces of ham, all right? And you know me, I like my little tables. So my goal is to make a ham sandwich. So for every ham sandwich, for 1 ham sandwich, ham and cheese sandwich, sorry, getting my letters mixed up, it takes 1 piece of ham. Remember how we always had to have what we were trying to get out of on the bottom? So see, ham is gone. And so 6 times 1, I'm going to make 6 ham sandwiches, ham and cheese sandwiches. All right. So I've converted the amount of ham I have to the amount of sandwiches. All right, let's do a different one. So that's what I started with. Was I had a reactant and I was figuring out how much product. All right, let me do this one. Let's say that I have 14 pieces of bread. Okay, and I want to know, how much cheese do I need? Okay, that's my question. How much cheese do I need? Well, if I know that for every, I always write down what you've got. So I'm starting with 14 pieces of bread. All right, what I'm trying to get to is cheese. So 1 piece of cheese, it takes 2 pieces of bread. All right, bread cancels. I need 7 pieces of cheese. See how I converted bread into the amount of cheese that I need? All right, let's do a different one. All right, let's say that I've got 97 pieces of bread. Okay, how many sandwiches? Okay, that's my question. So I start off with what I'm given, 97 pieces of bread. All right, for every 1 ham and cheese sandwiches, it takes 2 pieces of bread. So when you calculate, anytime I have something underneath, so 97 divided by 2 is going to give me 48.5. All right, well, there's no half sandwiches, so that means I can make 48 sandwiches. All right, so that's what stoichiometry is all about. It's taking what you're given and trying to figure out what you want. Okay, So I'm going to start you off with another problem. And like I said, I wanted to use this ham and cheese sandwich so that you could just kind of see how really this is what we're doing. We're just using bigger numbers. We're just having to do a little bit of conversion because, if I'd have said that I had 5 grams of bread, you would need to know how many, what's the molar mass. So see, we're going to tweak it a little bit. So here's my question. All right, it says how many grams of iron 3 oxide are produced when 42.7 grams of iron react with oxygen gas. So the very first thing that you have to do is you have to write a balanced equation. All right, so if you look, it says that iron is reacting with oxygen gas, and then we're producing this. So Fe plus O2 yields iron oxide. Now, is this a balanced equation? No. So the first thing I'm going to do is I'm going to balance my oxygens because they're going to be a little bit off. All right, that's going to give me my 6 oxygens on both sides. Now I need to put a 4 here, and I've got a balanced equation. All right, so step 1 is always make sure that you've got a balanced equation. All right, so step 1, make sure to have a balanced equation. All right, so step 2, always write down your given. All right, so here is my given amount, 42.7 grams of iron. All right, step 3, you've got to have it in moles. All right, so this is going back. Remember I told you we're combining chemical reactions with our mole conversions. So if I'm in grams and I want to get to moles, I divide. So 1 mole of iron equals 56 grams of iron. Notice that now my iron is gone, okay? And my grams of iron is gone, and I'm in moles of iron. All right, so then the next step, okay, so step 4 is do your mole ratio from the balanced equation. So the way you're going to do this, you always put what you're looking for. So this is your want is up top, your given is down bottom. What was my given? Here's the problem that most people run into. They want to put this as my given amount. You only use this one time, okay? Your given, this W and G that I'm looking for, comes out of here. So my given was iron, and so that is 4 moles of iron. My want is iron oxide, so I have 2 moles of iron oxide. So this part right here, this is why we need a balanced equation, because we get the whole coefficients and place here. What I want, see how many grams goes on top. What I'm given goes on bottom. Now, step 5, and I'm running out of room here. Let me change to a different color so we can see. Step 5, convert to proper units. So first of all, notice how moles of iron are gone, and I am at moles of iron oxide. I want to know grams. So calculate the mass, which is 160, divided by 1. And when you put all that in the calculator, my timer's about to go out. So you're going to do control divide, 42.7 times 2 times 160, arrow down to do control